have a review sheet? Or not a review sheet, sorry, note sheet. Note sheet. So, we good?
Yeah, Jerry's on her room.
She should be right back. Yeah. I forgot. Now, chapter 7 is going to be all about rational functions, rational equations. And we've talked about rational numbers. Rational numbers are fractional numbers. And these rational functions, we're going to have variables in the top and bottom of the fraction. So this here is a rational expression, but the variable is going to be in the top and bottom. And we're going to be evaluating these and working with these. Now, before we dig too deep into this, we're going to talk about inverse variation and direct variation. Inverse variation, it's a little bit clearer on y'all's page. I need to clean that up. Y equals a over x, where a is just a number and x is a variable. And we call this an inverse variation because as one number increases, the other is going to decrease. Where x is, or a is different than 0. So y equals a over x is one version of this. We can multiply both sides by x, and really we can say x times y is equal to a, this constant amount. It's still inverse variation. These are just different ways that we can write it. And it's said to vary inversely. So as x increases, as the numbers that we plug in for x increases, the value for y's are going to decrease. Or as x decreases, the value of y is going to increase. They're going to go in opposite directions. Now the other one we have is direct variation. Direct variation comes in the form of y equals a times x. Or we can say that we can divide both sides by x, get a by itself. Y is over x is equal to a. Because when we divide those two variables, the numbers for x and y, we should get a constant amount if it is direct. Questions on this so far? Now, x and y are just variables, so we could really also interchange them. Because I could also say that y is equal to a times x. X is equal to a times y. It's the same thing. Both of those are variables. We just have it in a different looking form. Or we can say x over y is equal to a. Same thing's true for inverse. Direct variation, the difference between it and inverse, as the value for x increases, the value for y is also going to increase. Direct variation, they're going to either both be going up or both be going down. They're going in the same direction by a constant amount, which is a. Questions on direct or inverse? All right. First thing we're going to do is tell whether x and y show a direct variation, inverse variation, or neither. So if we look at the first one, a, x, y equals 5. X times y equals 5. Well, direct variation we said is y is equal to a times x, or y over x is equal to a. Inverse variation, we said y is equal to a over x, or x times y is equal to a. So the first one here would be inverse because it does match up with our x times y equals a. X times y equals a constant amount. So we're just matching them up. Y equals x minus 4 is going to be neither. There's one main giveaway. Minus 4. And all these here, we have either multiplication or division. One or the other. We don't have addition and subtraction. When we talk about inverse and direct variation, it's going to all be either multiplication, we're multiplying two things, or dividing two things. Addition and subtraction does not have any impact on that. C would be direct, because y over 2 equals x. Now, x and y are on the same side, and both are in the numerator. So it is going to be direct. Now, another way to look at C, y divided by 2, I could say is the same as 1/2 times y. So we're really multiplying 1/2 by y to get our number. That's why they're the same. Another way we can look at this is I can get y by itself. And to do that, I'm going to multiply both sides by 2. Because on the left-hand side, we'd have 2y over 2 is equal to 2x. Well, our 2y divided by 2 is y equals 2 times x, 2x, which is still direct. If both variables are in the top and not being multiplied together, we're looking at direct. One's on top of the fraction, one's on bottom. On opposite sides, it's most likely inverse. But again, with identifying with the set equation, we're really just looking back at which equation matches with which. Questions on this here? Let's look at number 1. 6x equals y. Could be direct, because it is matching up with our y equals a times x. They just kind of have it flipped. 6x equals y, y equals 6x. Would be direct. X times y equals negative 0.25. It would be inverse. Our x times y equals a. And the a of value for this would be negative 0.25. Neither, because we have addition. The inverse for the first one. Neither for B. C would not be neither. It would be direct. So another way we can look at this is 1/10 y equals x. Or we can multiply both sides by 10, telling us y is equal to 10x. Both would give us the same amount. Yeah, x and y are just our variables. We can interchange them, switch them, look how they look. Questions on how we classified direct, inverse, or neither with a given equation? We feel kind of comfortable with these here? All right, now we're going to do it with numbers. Tell whether x and y show a direct, inverse, direct variation, inverse variation, or neither. Now there's a specific equation we're going to use with both of these here. And it's these two here. Now the reason we're picking these out of all the equations we've seen so far for direct and inverse variation is that both of these equations here have that constant a by itself, yes? And what it means for direct variation, when I divide the y values by the x, the corresponding y with corresponding x, for each set of numbers, I should get a constant amount. I should have the same amount of change. Because direct and inverse variation, I need to clean this slide up a little bit. Two variables show inverse variation when they are related as follows with a constant a. A is the constant of the variation. It's going to be the same as it changes from one amount to the other. So as we change the x values, here we're changing by a factor of 2, the amount that the y changes in correspondence to that x should be the same for it to be inverse or direct variation. So if we looked at direct variation, so direct, y over x is equal to a. As we take each y value and its corresponding x and divide it, we should get the same amount if it is direct. So if we look at the first number, the y value is negative 12 and the x value is 2. What's negative 12 divided by 2? Negative 6, yes? Okay, let's go to the next one. Negative 6 over 4. It would be, or it would reduce at most to negative 3/2, yes? They're not the same. We do not have the same constant amount, do we? Because it's negative 6, negative 3/2. So that tells us direct variation is not it. It is not varying directly. Inverse variation. Y times x equals a. So we'll do the same thing. Here, y for the first one is negative 12. X is 2. X times y, y times x, either one works. Yeah. Since we're multiplying the 12 and negative 12 and 2, doesn't matter the order. But negative 12 times 2, 2 times negative 12 should give us negative 24, we agree. Then we can move to the next one, 4, or negative 6 for y, 4 and 12. Negative 6 times 4 is going to be negative 24. Negative 4 times 6. And lastly, negative 3 times 8. So this would be inverse because that x and y are relating to each other with the same proportions every single time, no matter which x and y we pick. Since it has that constant a, the a in this case is negative 24, we do have an inverse variation. Does that make sense? Questions on this here? Let's look at B. We can start off with direct. Y over x is equal to a. Now the first y value we can pick is 2, and its corresponding x is 1. Well, 2 divided by 1 is 2. Our next one would be 4 over 2, which is 2. So I think we got direct, yes? So let's just keep going just to make sure. Because 8 divided by 3 is not 2. It would actually just be what? Repeated, yeah, 2.6 repeated. So it's not 2. So direct is out. Inverse. Y times x is equal to a, or x times y is equal to a. So we have 2 times 1, which is 2. We have 2 times 4. Neither. As soon as we get one that doesn't work, we can immediately cancel it out. But if it continues to work, we need to make sure we check all the numbers that are given. Because it could be that it worked on the first 3 numbers they gave us and not on the 4th. So we got to make sure. Questions about this here? Look at number 4. Direct y over x equals a. So we can start off with 20 over negative 4. 20 divided by negative 4 is negative 5. 15 divided by negative 3, negative 5. 10 divided by negative 2 is negative 5. And lastly, 5 divided by negative 1 is negative 5. So this one here would be direct. We don't even have to check inverse because it's going to be either direct, inverse, or neither. It's only going to be one. There won't be two. As if we went through and multiplied 20 times negative 4 is negative 80. 15 times negative 3 is negative 45. They're not the same, so it doesn't work. It's only direct. Questions on this here? For number 5, do we want to try direct or inverse first? Okay. X times y equals a. So our first one would be 1 times 60. 60. The next one is 2 times. And 3 times 20 is still 60. So this would indeed be inverse. Because x values are going away from 0, the y values are going to 0. So they're going in opposite directions. On number 4, the x values are going to 0, and the y values are actually going to 0. They're both heading the same direction. Because it seems like for 4, they're actually going in opposite directions, but they're actually going in the same direction. Because if we go past it, I think 1, 0 would be 0, then 1 would be negative 5, 2 would be negative 10. So kind of go in the opposite direction. Questions on this here? You can see another example of how to tell if a set of numbers is direct, inverse, or neither. So we feel kind of comfortable with this? Yes? All right. Might as well move on to the next part. Because if we feel comfortable with that, I'm not going to bore you with doing extras. The variables x and y vary inversely. And y is equal to 4 when x is equal to 3. Write an equation that relates x and y. Then find y when x is equal to negative 2. There's 2 parts of this. There's 2 parts, there's 2 answers. 1, we need to write an equation. And 2, we need to find y when x is negative 2. There's 2 parts to it. Now, since it says it varies inversely, I normally start here, y equals a over x. Now, the only thing we're missing from this here that we need to have the equation is the value of a. Because if I have the value of a, we can plug it in, we have the equation. So all we're missing is a. Now, they told us that the value of y is 4 when the value of x is 3. So what that means for us and this equation that whenever we plug 4 in for y and 3 in for x, this should give us a true statement for whatever a is. Yes, because when I divide this a value by 3, I should get 4. To solve this, first thing I'm going to do is multiply both sides by 3. 3 and 3 here cancel, giving me a by itself. And 4 times 3 is 12. So the value of a for this is telling us that the equation y is equal to 12 over x. Write an equation. We did that. That's the first half of the question. Guess who wants the equation? Second half, find the y value when x is negative 2. So all I have to do is take this equation and plug negative 2 in for x. 12 divided by negative 2 is so the other part is y equals negative 6. We need both parts. I need the equation, I need the y value. I'll take it. Thank you. Questions on this here?
So is that all?
Yeah, because I found the equation, and I found the value of y when x was negative 2. Not too bad. The variables x and y vary inversely, so our y equals a over x. And y is equal to 8 when x is equal to 4. Write an equation that relates x and y. Then find y when x is 16. Bless you. Now we could start off again with y equals a over x. Or, I just realized, what's our other equation for inverse that we talked about? X times y equals a, yes? What's the value of x? 4. So I'll replace it. What's the value of y? 4 times 8 is? So we can use that equation just to find a. Because again, that's what we need to find first. Because the other way we would have done this is what? Y is equal to a over x. So 8 is equal to a over 4. What would we do? We would multiply both sides by 4. Those would cancel, giving us a by itself, yes? What are we doing on the other side? 4 times 8, yes? What do we do on the previous one? It's still. Both work, both do the same thing. One, we just plug the two numbers in and find it. The other, we have to actually solve it out. So what that tells us is the equation. Y is equal to 32 over a. That's the first half of this problem. The graphing calculator, fractions are alpha, y equals enter. Now the other part of this question is to find the value of y when a is negative 16. Well, 32 divided by negative 16 is negative. I got two. If it doesn't reduce, we can just leave it as a fraction. Questions on this here? Questions on any of this so far? Do we need to see another example of one of these here? That's it. Especially when finding the value of y after you find the equation, if it doesn't reduce. Like 9 divided by 4. Leave it as 9 divided by 4. But that's it.